If you are ready to start getting your setup going, there's a link here you can use that will get you both the slides and a document to help getting started. So if you've got some time, you can start working your way through that, get a little ahead. Minikube, should that work?
We need at least 115. So if this is, yeah.
Yeah, I think it should work, yeah. Uh, 1.15 or 1.16 are what we're going to be using. We've got everything you need to use either. Yes? Sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, let's go ahead and get started. Thank you for coming, everybody. Thank you for coming. I know this is kind of at the end of KubeCon, and I'm pretty excited. Hi.
Yeah, just
Testing, testing. 1, 2, 3. That sounds better. You've got to use rapid channels. So I'll show you how to do that in just a moment. But yeah, it is there. It's just hidden away a little bit. First of all, really quick, let's just go ahead and introduce ourselves, and then we will start getting set up. My name's Joe Betz. I work at Google. I'm an etcd maintainer and a contributor to API Machinery. Most recently, I've been working on bringing CRDs and webhooks to GA.
Yeah, I'm Stefan. Many of you might know me from my CRD work, so lots of the CRD features you will see today, I was somehow involved or even was driving them. Yeah.
All right. So this is designed to be an interactive tutorial. If following along is optional, it's pretty complete, so there's plenty to watch if you just want to, but following along is encouraged. I'm going to leave this link on the bottom of the slides for the next couple slides. It's got everything you need to go ahead and get started. It's also got a link to these slides, so if you want to jump around or be able to copy and paste out of the slides as we work, I'd encourage you to get that open in a browser. We're just going to do 3 steps to get started. The first is we're going to create a Kubernetes cluster. And there's a couple different ways you can do that. Then we're going to check out our tutorial project. And lastly, we're going to set up some basic Go development tools so we can write some real code. There's 2 main ways that you can get a Kubernetes cluster started. You can bring your own cluster. So you could use something like Kind, or if you have a cluster already running somewhere, you can go ahead and use that. The main restriction is it needs to be 1.15 or newer. We're going to be using some more modern Kubernetes features. The other option is we have some Google temporary cloud accounts around in the room. If you already have one of those, you can go ahead and get started with that. If you don't have one, we should have plenty. So you can either just look around or raise your hand and we'll get you one. Occasionally those don't work, so if you have trouble with one, just get a replacement and you can keep going from there.
So about the slides, I've updated some slides in the SCED website of this talk, so if you want to look something up, just go there. The PDF is up to date.
And the first thing I'm going to go over just briefly is how you go ahead and create a GKE cluster if you're using the Google Cloud account. You can do that from the command line if you already have Google Cloud, but usually it's pretty straightforward to just do it from the web UI. Now, if you are already using Google Cloud for other things, you might want to use an incognito window for this. It keeps things nice and separate. It makes it really easy to log in and then clear things out when you're all done with the tutorial. But the first thing you're going to do is just navigate to console.cloud.google.com, and you'll be immediately prompted for the username on the temporary account. Once you've logged in and accepted a couple of the terms, you're going to have the option to you're going to see an option to select a project at the very top of the window. Open that, and there's a pre-existing project called Multiversion CRDs. You just want to select that one. After you've done that, you're going to navigate using the very top left of the navigation. There's a menu. There's like 3 little horizontal bars. Click that. Go down to Google Kubernetes Engine and click Clusters, and then you're going to create a cluster from there. There's only 2 things you need to do with your cluster. You're going to create a standard cluster. It can just be zonal. You're going to give it a cluster name. I'm going to use this name here of KubeCon-CRD-tutorial throughout my slides. So if you want to be consistent with the slides, you can just use that. And then you need to click Use Release Channels to get a new enough version of Kubernetes. It's really important that you do this and you get a 1.15 or newer version. If you accidentally created one older than that when you got started before, go ahead and just delete it and create a new cluster. The next thing we're going to do is set up, and it's okay if you fall behind me here, you'll get caught up, is we're going to set up our development environment a little bit. So we would encourage you, if possible, to go ahead and just use your local machine. Use your terminal on your local machine and do everything there. If for whatever reason you can't do that, you can use the Google Cloud Shell. And we don't have a super packed room, so we might actually have good enough connectivity for a lot of people to do it this way, but still your terminal is going to be the most reliable way. If you do use Google Cloud Shell, I'll show you how you can do everything from inside there. So if you're doing local development, the first thing you want to do is install gcloud. That will allow you to connect your Kubernetes, your GKE Kubernetes cluster. So go ahead and start getting that downloaded, and then you're just going to run 3 simple commands to log in, load up your project, and establish a connection for kubectl to that project. If you're using Cloud Shell, once your Kubernetes cluster is running, you can kind of see with the red circle I've got down here in the bottom right here, there will be a connect button that appears. You can just go ahead and click that, and then click Run in Cloud Shell, and it's going to open a terminal for you right there in your browser. It's going to be pre-populated with a command. Just enter to run that command, and then you should be able to use kubectl. The second major thing we're going to do is we're going to check out this project. You can do this either in the Cloud Shell or locally. Just clone this GitHub project, and then be sure to CD into it, because this is going to be our working directory for the remainder of the talk. If you're using Cloud Shell, you can get a basic editor. Once your terminal's opened, there's this little button right, let's see if I can get a pointer up for you.
Top one.
Thank you. There's a little button right here, it looks like a pencil. If you click that, it will open a web-based editor for you. It won't have all the bells and whistles of a full IDE, but at least we'll be able to do some basic work in it. You can go ahead and click that to open it up. If you're doing everything locally, make sure you have Go 1.12 or newer. We've got Go modules all vendored into the checkout, so you shouldn't need to pull much from the internet, but you'll need Go 1.12 or newer. If you don't have that version, go ahead and download it now and get it set up. Also encourage you to, if you use an IDE like IntelliJ or Visual Studio Code, go ahead and start connecting to the project now and getting that set up. We're going to want to have code completion and all the good things of a modern IDE when we do development. At some point, you should catch up with us and run these 2 sanity checks, and once they're both passing, that's a pretty good indicator that you're ready to go. Keep working, and while you do that, I'm going to hand it over to Stefan to talk about advanced CRDs.
Yeah, before I go into details here, I want to hear about your experience. So who has created some CRDs in some projects? So most of you, that was our hope. Who has programmed controllers or anything with client Go? Also most of you, yeah, maybe a bit more than half of you. Who has looked into the more advanced things like admission webhooks? Also a couple. So webhooks are already available for quite some time, and we will use them. We will show one example. Who has used Multiversion? Very good. Just very few. I think, yeah, in a couple of months, maybe some more CRDs will use this feature. It's pretty new and pretty cool, and yeah, we will learn today how to use it, how to write a conversion webhook. We have this slide here about all the features which we call, yeah, I mean, from right in the circle to the left, what we call advanced. So open API schemas, I guess most of you have used them in some way or the other. They are available for, I don't know, for more than 2 years, I think. The tooling around was always not so advanced. This has improved quite a lot in the last half a year. We have controller gen from controller tools, which can also create open API schemas. So yeah, look at this controller tool, controller gen binaries. This is really powerful and proven in quite a number of projects meanwhile. So OpenAPI has become much more feasible or usable in your projects. Beyond what controller gen creates, you can also do some validation which is more advanced, like you can validate values of fields in a CRD. And there are many OpenAPI features, like you can define a minimum, you can have enums for strings, regular expressions, many more things. And if you go to this controller gen tool from the controller tools repository, they have a book from KubeBuilder, so it's part of KubeBuilder, this controller gen. And the book will show you all the markers to make use of those special value validations. So it's all pretty boring because we know that for 2 years already, but we have some new things in the last versions. The first one is also very easy to use. It's preserve unknown fields. It's known under the word pruning. This will be, or it's a default in V1 API, CRD. So if you have a CRD and you use the API V1, which is available in 1.16, this is a default. So you don't have to do anything to get pruning. I'll show later what it really does and how it's used. But it's just one field and very simple to enable. So there was not much Go yet. So everything was in YAML, so looks very simple. Multi-versions exist for quite some time. Also YAML, you can define multiple versions in a CRD and they are served. But before we had actual conversion, so it's the next top here on the left, before we had conversion, all versions were the same, so there was not much sense. I mean, you could define them, but they all look the same. At least they had the same schema. With conversion, this changes. So conversion, it's a webhook written in Go. I mean, any language can do that, but the libraries and types, everything is in Go, so it's maybe the preferred language here. It's another step, it's another level of development. That's why we called this talk here something around a development project. We write Go code, it's much more than YAML. And the last thing, it's not so new, admission. It's of course also a webhook, usually developed in Go. Yeah, so this is our agenda for today. The first thing we did already, Joe will introduce the example in some seconds. We will use code generation, especially this controller gen tool. You will start the simulator and all the components of this example and the simulator. We will go into open API generation because it's not so new, but this generation is new, and we want more people should learn about controller gen and how nicely it works and makes all about OpenAPI much easier. Pruning will be enabled, and in the last part we go to Go and we will look on versioning. So we write a versioning webhook, conversion webhook, and we will test this webhook. We will write round-trip tests and deploy the thing in a cluster and see different versions being magically converted. And last but not least, there's the admission part where we will write an admission webhook, which is non-trivial, so it does more than just validating something locally by some unstructured object, but it will also access different resources, so it's much more than what you can do with OpenAPI. All right, so now we know what we will do, and Joe will introduce the
All
example.
right. Thank you, Stefan. There's going to be a bunch of interesting code to do. So for our example today, we're going to be working with some research on this thing called the Deep Sea Research Station. It's kind of hidden down there in the water. It's a big metal tube. It's really important to these guys. That's what they do their research in. And up here in front, we have Walter. Walter's nice. We like Walter. Up at the surface, we have about 1 bar of pressure. That's a unit of measure. We're just at atmospheric pressure. That's basically where we all are now in this room. This research station is down deep in the water at about 90 meters, or 300 feet or so. And down there, it's about 10 bars, so 10 times the pressure pushing in on every side of this tin can that our researchers live and work in. So it's really important that we keep the pressure inside our research station at 10 bars as well. If the pressure were to increase too far, the station could burst. If the pressure were to decrease too far, the station could implode. So we don't want either of these things to happen. Remember, Walter's inside, and we like Walter. Now, our research station is sometimes connected to a surface vessel through this cool thing called an umbilical cable. It's this conglomeration of different things. It conveys electricity and data and even air between the surface vessel and our research station. I'm going to focus in on that last item there, air. That's really important. We've now opened a conduit for airflow between our research station and the surface, which means the pressure could change. Fortunately, we've got some pumps we can use to help manage this. Now, the way that our pumps work are really simple. If our pressure is too low, we can run more pumps. If our pressure is too high, we can run fewer of them. Equilibrium should usually be about 3 pumps. We've got 6 pumps total. And we're going to do all of this with Kubernetes. And so here's a kind of a quick glimpse at 2 of the custom resources that we're going to be dealing with today. We have devices, which are just these kind of the general Internet of Things type of items. And we're going to represent those here in an API group called things.kubecon.io. And we're going to give them all names. And all they do is have inputs and outputs. Now, inputs are things from Kubernetes, so those are in the spec. Outputs are things about our device, so those come in through the status. You could imagine some connector connects to some external device and reports the output status and the observed inputs of that thing, and then the only thing we can do is set inputs. Now, we also have our research modules. We have 3 of them. We have a command, and a research, and a crew module. And all of them are going to have a custom resource that looks kind of like this. Each of them has 3 devices, a pump, an alarm, and a sensor. And we're going to be using this CR to refer to the other CR. So here we know that this module's pump is pump number 1, so we could then go look that up. So there's a little bit going on with our CRDs here. Now, to make this a little more fun, we're going to deal with multiple versions of our CRD. And the one that we have multiple versions of is our device. We had originally created a v1 alpha 1 where we defined 3 fields for all inputs and outputs. We had the name of the input or output. We had some value, which was just this quantity string. And then we would declare the type separately in a separate field. And we could say it was an int or a float or a Boolean. But there was nothing really tying the type checking of that value to what we said the type was. So later we came back and introduced a v1. And the v1 is structured a little differently. You only have to put an optional integer, float, or Boolean field, and then the value can only be an actual value. So our Boolean is now actually true or false. It's not just 0 or 1. This is a little better. But the key thing I want you to know from this slide is that both of these versions of our CRD are available at the same time, and clients are using them both concurrently. Some clients are using v1 alpha 1, other clients are using v1. They can both read and write to our CRD. They are both being served concurrently, and we're going to deal with that. That means that there has to be some conversion going on. We have to choose which version we're actually going to store. We'll talk more detail about that shortly. Now, we have a UI for our simulator. We're going to load this into our clusters in just a moment. And what it will do is it'll actually show you in real time all 3 of your modules for your research station and the current values for all the devices. There's even some things down on the bottom where you can tweak the values, so you can experiment with them a little bit. And we'll be working with that for the remainder of the talk. Now, how many of you have gotten to the point where you have a working cluster? Oh, great. OK. How many of you have checked out the code? Awesome. OK, so that's what we're going to do next is we're going to start looking through that code. So go ahead and open up your code in an editor, and I'm going to give you a couple pointers. The first place I'd like you to look is in the APIs directory. Inside of here, you're going to see all our API groups, both the things group, which is where our devices reside, and the deep C group. Inside of there, you're going to see types.go files that define our different CRDs. This is the source of truth for our CRDs. We can change this and change the structure of our CRDs. From that, we're going to generate two different things. We're going to generate our manifests in the manifest directory, and you can go ahead and open that up, and you'll see that we have Kubernetes 1.15 and 1.16 subdirectories, and pick the one that matches what you're using. Inside of there, you'll actually have your CRD definitions. The open API spec inside of that was generated from the APIs. The other thing we generate is in the generated directory, we have generated Go client bindings. We're going to be able to use those when we write code. In addition to those main things, which are all related to the types, we have an admission, a controllers, and a conversion directory. Those are all where we're going to be writing code. The admission contains an admission webhook, conversion contains a conversion webhook, and controllers contain some controllers that we're going to be using with our CRDs. Our examples directory contains some actual custom resources that we're going to load into our cluster in just a minute so that we have the modules and the devices for our specific example. And within the conversion, admission, and controllers directories, there are manifest.yamls that we can use to load those things into our cluster. And I'll show you how to do that in just a moment. For convenience, we have in our hack directory 2 code gen utilities. These are pretty small. You're encouraged to go ahead and look and see what they do. Mostly what they're doing is setting up the parameters to call our code gen tools. And we can use those to regenerate our client bindings or to update our open API schemas inside of our CRD definition. At the end of the talk, we're going to be using some Docker repositories, and our make file has some utilities so that we can easily build and push our Docker images. So we'll get back to that later. But the first thing I'd like you to do is just go ahead and start executing these few commands. The first one is going to load your Kubernetes CRDs into your cluster. Use the appropriate version for the cluster version that you started. Once those CRDs are created, we're also going to load up a conversion webhook. We're going to need that from the get-go. We'll continue to improve it later, but we need it running from the very beginning. So go ahead and run kubectl apply on conversion manifests as well. Next, you can go ahead and run kubectl apply for all 3 of our modules. And once you've done that, you can go ahead and do kubectl git to have a look at all the CRs that you've loaded. We added some custom columns to our CRDs so that you can kind of see some of the device values more easily. Once you've done all that, the next thing we're going to do is run our simulator. And so it's in the simulator directory. There's a manifest YAML there. Kubectl apply that as well. And then to get access to it, there are 2 options. You can either use port forwarding, which is option B here, which will kick on almost immediately, or you can open an ingress if you're using GKE, and it will take about a minute for the address of that ingress to appear and another 3 to 5 minutes for that actually to become available. You get a 404 for a couple minutes, and so you'll need to do kubectl git a couple times to get that loaded. But go ahead and run those commands, and either, depending on which one you use, either on port 80 or port 8080, you're now going to have your UI. So you can go ahead and get that loaded up. Or if you just prefer to do everything from the command line, you can use this watch command, and you'll get roughly the same information, just in a different presentation. Here, these are what are called quantities. That's a Kubernetes type. And the M just means, I think, millis. So this would be 10.2 there as the first pressure. Once you get your simulator started, you might notice that there's not a lot going on. You can manually change the values, and you could read them back using kubectl if you wanted, but there's not really a lot happening. So we're also going to start up a controller that's going to simulate some pressure changes. It's going to kind of sinusoidally increase and decrease that pressure over time. So once you kick that on, you'll see that these values are starting to change fairly rapidly. And we'll continue to work on introducing additional controllers to keep that pressure as close to 10 bars as possible later. So again, here's all those commands you can run. Continue to work on that, and hopefully you will be all caught up with us soon.
Yeah, so I will also prepare our local cluster here. So we are working with a kind cluster on this notebook. So it's running. You see the binaries we want to deploy, a couple of pods. So admission webhook is a pod. It's pre-deployed, so I did that already before the talk. Simulator is running, and the conversion webhook is running. I will, here at the bottom there should be a port forward, so this was option B on the slide. So we have a port 8080 which references or is forwarded to the port of the simulator, and if everything works well, we should see something here. Not much is happening. Everything is static. There's no action yet in this cluster. So every of those pods is waiting. We have to deploy the controller to get something here, which is more interesting. So let's do that. We have a controller directory. As said before, there's a manifest inside, and if we do that, within some seconds, we should get a controller, container creating, and an error for whatever reason. I have no idea. It's not essential. So it's not doing much at the moment. The controller just increases or decreases the pressure. So no pump is on, so there's nothing which updates the pressure. So I think it just decreases, right?
Yeah, unless you set it to 3 pumps exactly, it'll pretty much just decrease indefinitely.
So,
but you can go ahead and, if you want to see it just kind of vary up and down, you can leave 3 pumps active until we improve on that.
We can debug that in a minute during an exercise we do. So let's take a look on Open API. So let's make this full screen again. So you have seen those two CRDs before. We had them on the slide, and we will mainly look for Open API. At least we will look on the left one. So we're interested in specifying the structure of the device CRD. You can see here we have inputs. Inputs are values. Also the type inside of Go is called value. And the observed inputs and the outputs are also values. Everything is a value, basically. And the value in version V1 Alpha 1 has a structure here. It has a name, has a value, which is a quantity. So it's a string, actually, in the CRD. And it has this type, the integer. It can also be Boolean, or it can be a float. Inside of a CRD, you have to specify Open API. So you see this looks very similar to the structure of the CRD here. In the middle, where this blue bar is, this is the Open API schema for version 1. So we have a version 1 here. I think I switched the version on this slide. So yeah, I did. So here, this was the old V1 Alpha 1 type. Here we have the V1 type. It's a bit simpler. So integer is really one field. It's a sum type. That's how we call it. Integer can be set, float can be set, or Boolean can be set. And on the right side, we have to specify or create somehow the schema. So this is the topic of this section. Just one word here about metadata. So this must be complete. We will show in a minute why it should be complete. So you have to specify everything you can have in your CRD. There's one small exception, the metadata, so the object meta from client Go. This doesn't have to be specified, and it even cannot be specified. So there's restrictions in the last version of Kubernetes. So you can say type is object, but don't start to specify every field below. So don't specify, I know, annotations and labels and stuff. Don't do that, it does not even work. If you have old CRDs which have that, because KubeBuilder created this originally, get a new KubeBuilder and regenerate. A CRD in 1.15 or 1.16 which wants to use new features cannot have those field definitions inside of metadata. All right, how to create that? We don't create it from the custom resources. It's just an example here on the left side. We create it from Golang code. And it's basically inspired from what we do for native types in Kubernetes already. We do the same for CRDs. So you start defining your types in Golang. So here's the value struct. As I said, it's the most important struct which is used for the inputs and the outputs and observed inputs. It's always this value. And you can see there's a pretty clear translation. So a struct becomes an object here, and the struct has 3 fields. So you have to define them as properties. So name, value, and type here from the left show up on the right side again. So you could write that manually, but of course we don't want to do that. We want to use a tool. And the tool here is this controller gen. It comes from KubeBuilder, from the controller tools repository. And yeah, there's a new command, subcommand. It's called schema patch. So this can be used to just create a schema. You write your CRD yourself. So manually you write a manifest for a CRD. And then you patch in the schema. So this can be done by this command line. Very, very simple. The command line can read any kind of manifest, CRD manifest here. You give it a Golang-like path of APIs. In our case, the Deep Sea API and the Things API in V1 and V1 Alpha 1. And it will match automatically. So it will read all manifests. It will read all APIs, all Golang types. And it will match them. So Golang types, there's this, a way to define the group name and the version, and it will match that with the manifest, and patch the manifests. So it's pretty convenient, just one command, and we have put another script here inside of the repository, update CRDs, but it's not doing much more than just calling that command. So use that, pretty cool. Schema generation is driven by markers. So the marker idea, it's everywhere in KubeBuilder. So you see those plus KubeBuilder comments inside of the CRD types here. KubeBuilder validation are those which we are interested here in. enum, for example, we want to specify that a type can only be one of those three values. And OpenAPI has enums, so you can define that. And there's an equivalent marker here, enum equal to, and then you give a list of values of strings. Here we use a default as well. So defaulting is new in 1.16. That's why we have those two CRD manifest directories. In 1.15, you don't get the default. So you have to, if you use 1.15, you want to update your schemas, you have to disable or remove this line where the default is actually specified, and then regenerate, and then you get something which is compatible with 1.15. But in 1.16, you have that, so it's convenient. If you don't give any type here, it will default to float. So every CR without types will be a float CR, which is pretty nice. It's pretty important to define what is required and what is optional. So OpenAPI has this required keyword where you just list the fields of an object which are required. And you can also specify that with markers, which is, it's here. Here's one, the name is required, and the value is required as well. Type is not. Keep in mind, if you require something, it's also required on the client side. And kubectl will validate. So kubectl will reject objects which don't have the required fields. And this is the reason why we don't have the type here as a required field. You can leave it out, don't require it, and say there's a default, and then you know every object gets this value, but technically it's not required. Anyway, it can never be empty because it's defaulting mechanism. We'll make sure that the value is set. Required and optional, those of you who have used KubeBuilder before, the default is that everything is required. And this is kind of unnatural for many people. That's why we built in a mode or mechanism to set a default for the whole package. So you can say KubeBuilder validation optional in the .go file, so at the root of the package. And then everything by default is optional, and you have to opt in into being required. So this is, for many cases, is much more convenient. And as I said before, this controller gen will match, so it has to know how group names are, what the group names are, what the version name is, and there are a couple of tags to do that. So you say group name is, in this case, things KubeCon IO. By default, it will use the package name, but the package name is just things, I think, in our case. So we specify that here explicitly. And the version name is v1. This should also be derived from the package name. I think in my case, there was a bug. That's why it didn't work in this version. Maybe it's fixed by now. That's why I specified that as well here. All right, so that's how OpenAPI is generated. Before we do that, actually, practically, some word about pruning. So pruning is default in V1 CRDs. The reason is that we want everybody to use pruning. Pruning is important because it removes fields from a CRD which are not specified. So you can always be sure nobody stores anything in etcd which is not defined by you as an author of a CRD. In V1 Beta 1 you can enable that as well, so just set preserve unknown fields to false. In V1 it's the default. All right, so in our case here, I said before, this must be complete here. So the schema should, it should mention every field which is in your CRD. So this is kind of automatic. If you use the generation, it's complete because the tool always creates all the schema. What happens if something is missing here? So you have a CR like this one, and there is unknown 42. Somebody just passed that or added that. It's not specified on the right side, so the schema doesn't include unknown. And if you create this object, it will just, the server will just drop unknown 42. Even if you skip validation, so kubectl will complain. Kubectl will, client side by default, will complain that unknown is not in the schema. But even if you say validate false on the command line of kubectl, unknown is dropped by the server. So you're sure there's never an unknown, only fields which you know. Yeah, and if you use the controller gen, and if you set this field, this is pretty simple to use. Just as a side note, we won't use it here. There are ways to opt out of that. So you can specify that a subtree of your CRD, of your CR, is actually pure JSON. So if you have something, you embed some JSON construct from another API, for example, there is a way to say that. So you can opt out of pruning, but it's not suggested. I mean, just do it there where it's really necessary. In the normal case, just depend on pruning. All right, so so much about OpenAPI. We have the first exercise here. So who's ready to work on the repository? Who has checked it out? So we have not, we forgot some validations. Names should be non-empty, right? An empty name for a device doesn't make much sense, yeah? Yes. It's not about the not the CRD API. It's about your API group you define. Yeah. Hmm? Hmm? If you use a CRD, like the API extensions, API V1 Beta 1, like you do in a 1.14, 1.13 cluster, because there was no V1. V1 is new. If you define a V1 Alpha 1 CRD for some kind of API group in an old cluster or using V1 Beta 1 in a new cluster, then pruning is not enabled. So you have to, if you use the old API for CRDs, you have to enable it manually.
But this is not the versions that you're defining for your CRDs. So you can call your versions whatever you want, and their behavior is not going to change based on that. This is the version of the CRD mechanism itself.
All right, so the task is to add the validations which are missing, obviously. Names of inputs should not be empty. Empty, I mean, you can do it. It's just strange to have empty names. And names should also follow some pattern. So what we want to have, names are just letters and numbers. So the task is to add that to the types. I added here this red remark. Everything you do, so we have two versions of the CRD, V1 and V1 Alpha 1. So everything you do, you should better do in both types Go files. If you do it just on one side, later on you will be able to create, in one version you will be able to create something, an object, which is not valid in a different version. So always try to match them. Try to have validation which makes sure that even after conversion, if you change the version of your object, it's still valid. So it should be non-empty in V1 and V1 alpha 1 in our case. And you should have the same character set as well. If you have done that, yeah, just regenerate. So what you are doing, you're working basically on the type-scope file, and you're adding markers. So here you have a couple of examples for markers. Just yeah, follow this pattern, add some markers for the name. There are the links for the book. So KubeBuilder has a nice book with a long list of markers. You will find the right ones pretty easily, I guess. And update the type-scope, update CRDs, so call the script. This one calls controller-gen internally. Apply the new CRD to the cluster and just verify that it's really now validating. So create an object or edit an existing object like an existing device and change the name into something which is invalid, and hopefully this is rejected. Yeah, and if you have too much time, if it's too easy for you, we have two advanced steps here. One is in V1 we have the sum type. So we have integer, boolean, and float. And there are fields in this value type, and just one is allowed to be set. You know that from volumes. Volumes in Kubernetes, they also have this sum type structure, so you have host path and empty and secret and so on, and only one can be set. And the goal is here to express that in OpenAPI. It's possible, it's not even so hard. Yeah, just try it. And yeah, the last one, this is really pretty advanced in OpenAPI. If it's Boolean, you better only have the two values 1 and 0. Not a half, doesn't make sense for Boolean. It's also hard to convert later, so if you want to add conversion, you better just have those two values. So try to express that. Just as a little hint, KubeBuilder is not able to do everything nowadays. So you might be forced to write OpenAPI directly into the manifest of the CRD. Yeah, and I think we give like 5 minutes or so.
Yeah, we'll give you a couple minutes to get that going, and then we'll keep going. Yeah, let's have a look at that. Let's try, and I noticed that we didn't have all the modules running. Let's see.
Ah, okay. This can be.
Let's first reapply our examples directory and see if that happens at all.
Research.
Crew.
And command.
Yes, and
Why doesn't it work? Delete what? What's my no? No, fine.
KubeCon. There we go. See what happens. Still not luck. I wonder if I should just build the controller again. Uh-oh. I think we're okay.
That was a pressure. Was too high. I delete some. Oops.
try Git and see if that works.
I don't know. That's a different arrow.
Okay.
Let's see. Quantity.
All right, how are people doing with their validation rules? All right. Okay, we'll get started in just 1 second. Let's see. Oh, I'm gonna have to do this dash.
All right, so yeah, we are trying to debug why the controller doesn't work here. There's some panic. It's not essential. The controller is just cosmetics to get some nice animation. Actually, we have a slide later where you see what really happens, so we don't need that for the moment. Very quickly, yeah, let's take a look here on one of the types. We are in which one? We are in devices v1 now, so we have this nice sum type here, and if we want to say that the name is not empty, there's the min length, and you can just say 0, and we have something called a pattern, so it's just a regular expression, so pattern equal, and I think you have to put it in the quotes, and it's A to Z, capital A to Z, 0 to 9, and we want anything. Of course, you can also use something like plus and then get rid of the min length, same thing. And let's see whether we have any effect if we do that. I update the CRDs. And you see that something was added. Was it? No, it was not. Why did he do that? It was not. I don't see it. Why was it not added? It works for you? So where's my typo or something like that? I know where my typo is. Everything must be capital. And please, I guess there's an issue to make this more, to make the error messages better in KubeBuilder. Give me some support, put a +1 there. You have seen why. And I hope we get something now. Yeah, perfect. So KubeBuilder, the controller gen, is not really good in error messages, so you don't see that something was wrong there. Okay, so I don't do the other examples for everybody who wants to see the solution, especially for the stretch goals. It's pretty complex compared to the one I just showed. But it's interesting, especially if you are interested in, or you know logic, propositional logic. This is involved here. All right, so exercise 1, next one. We want to have multiversion. So we have seen this before, right? Yeah. It should be a 1, you're right. Yeah, for length, even -1 doesn't make sense. Yeah, a 1, yes. Multiversion. So we have seen this before. We have 2 versions of devices, and we have seen already where the difference is. One has a sum type with those 3 fields, and one has just value and type. And important here is that you have to convert, and the conversion is something which is done in place, or it's really done live when a request is processed. There's nothing like some people think there's an object in V version 1 and it doesn't exist at the same time in V1 alpha 1. This is wrong. An object exists in all versions of the API group at the same time. Of course, etcd is kind of opinionated, so etcd will store just one version. There's something called a storage version, which you can define in the versions field of the CRD spec. But logically, when a client comes to the server and asks for an object, the client says which version it wants, and there is live lossless conversion into the target version that the client wants to have. If the version in the etcd is wrong, of course. I mean, if it matches, it's the same, there's no conversion going on. So we have to write a webhook. This is basically the reason why we need 1.15. Conversion via webhook, it's pretty new. It's new in 1.15 as a beta, and we promoted it to 1.16. So we need at least a 1.15 cluster. Multi-versions without conversion we had earlier, but it's not really useful. So let's look at our type value. As I said, all inputs are values, so this is really the core of the CRD. Here's a representation of which we invented in V1 Alpha 1 when we maybe didn't have lots of experience with API types, so we chose this representation and we don't like it. We want to offer this one, the right one, to the customers for a V1 API, and it's different, right? I mean, it looks, everybody sees there's some kind of mapping between them, but technically it's different and we have to convert. So we have to write a function which takes the left one and outputs the right one, and you have to write a second function which does the converse, so from right to left. That's our task. Conversion is enabled in the custom resource definition, so if you have the manifest of a CRD, you define versions. Most of you, even if you have just one version nowadays, you get this versions slice here in the manifest. As I said, one is the storage version, so one is stored in etcd. In our case here, it's V1 Alpha 1. For whatever reason, you can think about when it makes sense to really change the storage version. Of course, you change it at some point when you don't want to have V1 Alpha 1 anymore. But the interesting part here for us now is to add the conversion. This is a new thing. It's also in the CRD spec, and it's for all versions, so there's just one webhook. You cannot have multiple of them. It's always just one. You change the strategy to webhook, so if you do that here, you have to provide a client config, a webhook config, which has a client config inside. Client config is mainly, I mean, first it's a service, so a webhook must be behind a service. We have put this into the things namespace, and we gave the service name conversion webhook, and the path is just the HTTP path, which is called when the webhook is called. And it must be secure, so there must be a CA bundle as well, which matches the server insert of the webhook. It's all done in this repository. Everything is there already. The make file will be able to create that. You can take a look at that, how it's done. So it's secure by default, and our example does that as well. There is something we see in a second. We have conversion reviews. So there's an object that is sent to the webhook, and that's called conversion review. And this conversion review API, it exists in different versions. So V1 Beta 1 was the one we introduced in 1.15. We also have a V1 version of that nowadays, but we have based everything on V1 Beta 1 because it should work in 1.15, and as far as I know, it's also required that the webhook supports this version even in 1.16. So it's enough to have V1 Beta 1. But just about details in this object, they don't really matter for us here. And lossless conversion we have seen, and it can be that your webhook is called more than once. So it can be that it's called when something is read from etcd. So in etcd, maybe you have a different version than the request, and when it's read, there's a conversion going on. Then your request is processed, something is written back to etcd, and then a second conversion is going on. Just a quick glimpse here on what kubectl does internally. So if you say kubectl get devices, it will use the highest version it knows. So it's a preferred version, and there's a fixed order. If you have a V1, kubectl will use that. If you don't have that, it will try, it knows which versions exist. It uses discovery. but it will order them in this way. So v1 alpha 1 is not used by default, so you really have to tell it use v1 alpha 1. As soon as you have v1 in discovery, so in your CRD manifest, kubectl will use that. And discovery will make this just transparent for the user. If you don't deploy the conversion webhook and you just try kubectl get devices, it will still try to get a v1. But the API server will call out to your webhook. It will see, oh, doesn't work for whatever reason, 404 or connection refused or something like that. And the request will fail. So conversion is important as soon as you define a v1 in your manifest. All right, so I said already it's just a different picture of what I said before. That's the API server, and your request comes in. There's no conversion going on for CRDs. It's a bit different than for native types. The conversion happens for CRDs when it's read from etcd, it's converted to the version of the request, so from green to blue here in this case. The rest logic is done, like an update or a patch is done, and when it's written back, there's a second conversion, so expect 2 of them at least. There can be more if you have webhooks involved. Webhooks might require different versions. There might be many more of those calls to your webhook. But the normal case for a write operation is 2. At these 2 points in the API server calls out to your webhook. And to do that, you have to register. We have registered the webhook already. It's in the manifest of the CRD, so it knows about that, and it will do those calls. And those calls will get an object, so it's just a normal webhook, which is implemented via Go, for example, in our example here. So it's an HTTP server, and it gets some request. And this request, in the body, it has a conversion review.
Okay, so let's look a little more at this code. Great. So what we know now is if we register a webhook in our CRD with that stanza, the API server is going to know to start calling our webhook. And these are kind of the Go representations of the requests and the responses. So let's look a little bit at the code. In the conversion directory is where we have the code for our conversion webhook. And if you'd like, you can look briefly at main.go. We're not going to make any changes there, but it will give you a sense of what some of the setup and handling code for a conversion webhook is. And then the bulk of our actual business logic is over in convert.go. We've got 3 main functions that we're going to look at really briefly. And we're going to see how this works and how we test it and how we make sure it's right. So this is the main function, and it's only responsible for converting one object. We get lists of objects to convert from the API server, but we've already looped through that in a separate function and just called this individually. So our 2 inputs here are the object that needs to be converted and what we need to convert it to. The API version string tells us what we need to convert it to. We need to either successfully convert that object or return some meaningful error about why we couldn't. Now, in our particular case, we're only supporting a conversion of the device custom resource type. So in our switch statement, we're going to handle both of converting from v1 alpha 1 and from v1. So that's our 2 cases. And let's just look at one of those cases, because the other one's going to be symmetrical to it. So in the case where we get a v1 alpha 1, we're going to make sure that we're actually converting it to v1. That's the only other thing we could convert it to so far, because we only have 2 versions. So we just make a check on that. And then what we're going to do is we're going to return back a v1 device that is the same as the input, except that the values are different. Because that's the only thing that we changed about our devices, was how we structured our values. So you'll see everywhere we have a value list, we're just going to call a conversion function there. But otherwise, we're building a device result that is the same as what we were provided with. And we would do basically the same thing for v1, just in the reverse. Now, testing this is interesting. You really don't want to put something like this into production until you've tested it pretty carefully. And fortunately, Kubernetes has been building and testing converters internally for a long time for all the built-in types. So we can kind of leverage the strategies that have been used there to do some testing. And Go has a utility library called a fuzzer that we're going to take advantage of. What the fuzzer will do is if we give it some type, some Go type that represents, say, our device, it can populate that with values. Now, we're going to have to augment that a little bit. And so what we've done if you go and look in the APIs directory, you can see the directory here listed right up at the top. If you go and look at this file, what we've done is we've augmented our fuzzer to know how to handle and produce a valid value in the case where you can either have an integer, a Boolean, or float. These were all for kind of the purposes of the fuzzer. It just thought that these were 3 optional fields, and it didn't know that it should only populate one of them every time it creates an object. So we're telling it to do that. So we're just taking a random value between the value of 0 and 3 and picking which of those possible options to produce. And once we've done this, we've now told the fuzzer everything it needs so that it can generate valid devices for us. And you would do this for whatever types of objects you have. In the cases of basic fields, the fuzzer already knows what to do. In the cases where you have more complex types or validation rules, you might need to teach it what is valid. Once you've done that, then it gets pretty straightforward. Here we have some fairly general purpose code that's just iterating over the types that we have and the versions of those types. And then it's going to run 1,000 iterations of what we call a round-trip test. And so all we're going to do is take advantage of our fuzzer to create an object. We create an object X, we populate it with our fuzzer, we stamp on the correct version kind for it, and now we have a generated object. We then figure out which version we're converting it to, which is just the opposite version we're already at. So if we're already at V1, we're going to convert to V1 alpha 1. And then we just do 2 conversion steps right here. First, we convert it from the version we're at to the other version, and then we just convert it back again. That's round tripping. Once we've done that, we should be able to assert that what we started with is also what we ended with, right? As long as we can say it went back from one version to the other and then back again, we've round trip tested it. So here you can see that flow. You start with V1, you go to V1 alpha 1, you go back to V1, and you check if they're equal. And we'll do that in both directions. And we can actually run this. You can run this right there on your command line. You'll see down here we have a go test command that will run our round trip testing. And if you run it, and I'll go ahead and just do that, we're going to see that we have a problem.
So it's in the conversion directory, so it's part of the conversion webhook, and there's a convert test, and that's where we have put the tests here. And yeah, we have a very, very simple test convert, which just has 2 examples or something like that. And yeah, just smoke test, very simple, but it doesn't use fuzzing. And the second one, if you go down here, this is what Joe just talked about. And if we run that, and wait for compilation, everything is red. Why is it red? Yeah, what does this mean?
All right, so let's try and interpret this error. You can see from the error that it says round trip failed on devices, and then it says it expected something and got something else. Usually what I like to do when I get an error in Go is just find the code that printed the error. Failed to convert back to round trip failed. Oh, is that it? Yes, this is it. So this is the error. It was on our deep equal comparison. So let's look at what this does. First, it does a reflect.deep equal and checks if what we originally passed in is what we got back. And if that's not equal, then it prints our error, and it uses diff.objectReflectDiff to print out how the object it expected differs from what it got. And so A is what it expected, and B is what it got. Now this is it takes a little bit of Go knowledge to interpret what these 2 strings mean. The first string means that you have a slice of type v1.value, but it's nil. And the second one says you have a slice of v1.value, but it's empty. So it's not nil, it's just an empty array, so to speak, whereas the first one was actually a nil array. Well, that's a problem. So I think the next step would be to go and find where in the code that happened. So what we could do is go into our convert function, and I'll give you guys all a second to see if you can find it. But what we're looking for is when we have v1 values, and we converted those presumably from v1 to v1 alpha 1, then back to v1 again, because, and we were expecting to get a nil, but instead we got an array.
And this kind of analysis, we show it because it's what we do when we build APIs with conversion. It's really about very detailed and rigorous work to get things right, to get this equality which we had on this round trip 100% correct. So it makes a difference whether there is nil, which is a null or undefined in JSON usually, or it's an empty element, because you can imagine when you round trip, suddenly the object changes, and this is nothing you want to have. So it's really something we do every day when we build native APIs. It's the same procedure, the same steps here. You must be this detailed and get it as right as possible. Remember that we said exhaustive tests, so only test things. I mean, test as much as possible with fuzzing, with random values, but only validated objects. So there's no sense to convert something which is not valid. So this whole process here of getting round trips right, it's a kind of counterplay, or it's a counterpart of validation. In the moment you define the validation, like the open API based we have here, you also work on your round trips. So it's always both sides and get them to match. This is the basic idea here. And if round trip works and you are sure it's pretty exhaustive what you do there, what we test there, then you're pretty sure that validation is good, and the round trip is really something which is bijective, so it goes really without any data loss in both directions.
So I think I found the bug, so is it okay if I fix it?
Yeah.
All right. So I noticed that most of these conversions for values are taking in, let's see, that one's just scalars. Let's see, but I noticed that this one is working with arrays, but it doesn't check if the input's null, so I'll check that. So what if I might have you type, Stefan.
It's a German keyboard, I'm sorry. So you want to check if in is nil, right? And in that case, maybe return nil and don't go into this make, which gives you an empty list.
All right, so let's save that and see if I got it right. Sure enough.
All right, so 1,000 times it worked. The chance is high that this will be correct. In native types, actually, we have it sometimes, even after 1,000 iterations. In CI, there might be flakes. So maybe after 100 runs, we find some case, some random values where it's still wrong, but 1,000 is already pretty good.
But there are some advantages to the fuzzer. So for example, if later somebody went and added a new field to this, and it was just a string, the fuzzer would automatically pick that up and start testing it. So it means that in many cases, you're going to have to do less work to keep your tests in sync, which could result in fewer defects than having to manually manage that. So there's a trade-off. OK. Would you like to start with admission?
Yeah.
All right.
So maybe before I do that, I just show once in the terminal that it actually works. Right. So I haven't pushed the new change now. I mean, this nil is not really visible. It's not so important. I mean, it's important to get it right, but I haven't pushed it now. So get devices, as I said, it will just take the V1 version. Looks fine. Let's look at one of them and maybe show the YAML. Not the module I wanted to see. No, is this the device? Why is this? Because the controller doesn't work, right?
Oh, yeah, we got to figure out our controller.
If the controller worked, there would be values, so you don't really see a difference. But what you see at the moment, it's a V1, so KubeCon uses V1. And if you want to use a different version, you have to do it like that. So you have to write the resource name, then the version, and then the group name. And in this moment, the conversion is called. We could look at the conversion webhook now. There might be a log line. But you see here, it's now V1 alpha 1. So this works. Yeah. Here we actually have something. Why do we have? It's a list. I showed everything, not only. So we have some values here. And you see them. They are really the V1 alpha 1 variants, where you have the value and the type. All right. So much about conversion. So round trip testing, please do it. If you start with that, it's a super useful tool. And we learned when we really use that in upstream development, the chance is very high that we get it right. Conversion is hard, so don't be afraid. It's hard for everybody. Everything which is non-trivial in conversion to get it completely right and without data loss. It takes time, it takes gray hairs or gives you gray hairs. It's a hard task. All right, admission. A lot of things you can do in OpenAPI, but you cannot do everything. OpenAPI is limited to a certain degree. Especially, you cannot do things like here. I want to check if I create a module that all the devices actually exist. So it's something which is far beyond OpenAPI. So it wants to check devices live when a request for a module comes in. So if you create a module or an update a module, it will check that those 3 devices exist, so it has to make calls to the API server. So it's much more than you usually do with OpenAPI, which you can do. Admission, yeah, it's this big yellow block here in the chain. Validation of OpenAPI happens here, where this white block of validation is. Validation of or using admission happens just after, so we will add one of those blocks here on the right of validation, and our admission webhook server will serve that. So it will get every object, so there's one call per object or per request actually. We want to check, of course, create an update, because, I mean, deletes we don't care about whether devices exist, and gets we are also not interested in. So updates and creates are interesting, and patches are part of updates. So we really just need those 2. And our webhook implementation here down here, it will have a watch to the API server. So it will be called by the API server, but at the same time it also uses the API to get everything which is changed for devices. And we will use an informer in the code, so this is really fast because there's a memory cache of devices inside of the webhook. So it's not really a live quorum read to the API server. There might be some lag, maybe half a second, so it can be that devices already exist, but for this use case, it's good enough. All right, you have to register that the webhook exists, so there's some object called validating webhook configuration. Everything I talk about here, it also exists in a mutating form, so you can also register mutating webhooks to change requests, to change objects before they are created or updated. But we will just do the validating case here. But it's basically the same and not much more complex. This is a configuration, so the object which registers our webhook in the cluster. And you create this object, it's cluster-wide. We give it a nice name, deep C, KubeCon IO. Very important is the failure policy. So when our webhook doesn't work, like the pod goes down or something like that, or network goes down, we want to fail. So we can also react open on errors here. I think it's ignore the keyword. So if you put ignore here, it will try to call the webhook. If it gets a response, I mean, it will be followed, but if the webhook is gone, down, network error, whatever, it doesn't matter. But we want to fail here. So this is very, very important. We want to tell it when we are called. We want to be called on this API group, so our own. On v1 alpha 1, it's the only version for the modules. On create an update, and only on modules. Be pretty strict here. I mean, really restrictive. Don't put wildcards there everywhere. This is about the cluster stability. So if your webhook goes down, those objects, in our case the modules, are basically not working anymore. So be prepared. If you validate pods, for example, and your webhook goes down, you will have a hard time to restart it, because the pod for the webhook is also going through the webhook. And it's circle self-reference. So try to restrict it and be prepared for those self-references. Very similar to the conversion. Again, you have a client config here, so it's the same thing. I think it's even the same implementation behind. It's behind a service, and service has a name, and there's a path. And again, there's an admission review version. So admission reviews, the objects you get are versioned. We have v1, so admission is promoted to GA meanwhile, but again, there's a v1 beta 1 version for admission reviews, and we will just use that one. Yeah, and by that, API server knows everything about our webhook, and it will call it.
All right. So again, let's go look at some code. Here are...
Little typo, just the lower one we didn't change.
Oh, yeah. That should be a mission response here on the bottom, of course. These should all be symmetrical.
But it's a sign that those two mechanisms are very, very similar. So they use the same codes, the name structure, and the API.
Yeah, it's great. Now that you've already seen conversion review, you can kind of guess at how admission review is going to work. So I don't need to say too much more about this slide. Now, admission review has a lot more fields. This is great. This means that if you are doing security checks or policy checks, you have a lot at your disposal to compare against. In our particular case, we're just interested in the contents of what's being changed. We're not interested in who did it or what namespace it was in or things like that. So we're going to focus in on just two of the fields, the object and the old object. In fact, we're only really going to focus on the object because that is what we're going to change the value to. The old object for an update is what it was before it changed. That can sometimes be useful. And remember what we're doing here. We've got, in every single module, we've got 3 devices with device names. And we want to make sure that those device names that were entered in there only change to values that point to actual existing devices. Now, if it does match an existing device, we can return allowed true. That means that we are admitting this request, everything looks fine. If it doesn't, we're going to say allowed equals false, and we also should provide back some errors in the result saying why. This can go all the way back to the client. This is the only way they're going to be able to know what went wrong and how to correct their request. So if they fixed it and tried it again, they could be successful. It's very important to provide something useful to them there. Also, just in passing, now we're talking about validating webhooks. So this doesn't apply to us directly. But if you were to be building a mutating webhook, the patch is where you would send whatever change you want to make to the object. So since we see it here, I thought I would just mention it in passing. All right, so we're going to go back and look at some code. We're going to be looking in the admission directory. I'm actually going to go ahead and open that while we go. And let's see, go up to admission. And command admission webhook main.go. So this is our main admission webhook. And you can see some basic setup. There's our main. It's going to handle requests. And I think our handler is just right inside of that somewhere.
Just to give you some space.
Oh, thank you.
There we go.
Thank you. So somewhere in here, we're going to find a handler. And let's go ahead and just find that.
Yeah, if you go down. Here's the mux we created, so the multiplexer, and
module validation.
Here we create a handler func. So it's not rocket science, it's pure Go, very boring actually. It's just a normal HTTP handler.
Right. So now we have our handler function, and we can look briefly at some of the work that's done there. Now, one of the things we have to be able to do is get a list of valid device names. And the way that we're going to do that is we're going to use one of the Kubernetes client libraries called an informer. Basically, what informer is going to do is it's going to allow us to build an in-memory cache of all the devices right here in our webhook process. And then we can ask for requests to that. Under the hood, what's going on is a little interesting. And the informer is first going to list the devices that you asked it about, and then it's going to establish a watch, and it's going to keep that cache up to date. And if it ever gets too stale or gets out of date or needs to, it can relist and keep doing that. But at any given point in time, you're going to have this eventually consistent cache. And then we're going to use the type-safe bindings that we generated from our client types to do that. So we've got this nice, convenient way of saying things.v1alpha1.devices. So we know exactly what thing we're dealing with. And then we're going to create a lister. And the lister allows us to probe or ask questions to our in-memory cache. We can get or list those devices, and those are going to be really cheap requests because it's just a local in-memory lookup. So now that we have devices that we can check the names of, all we need to do is figure out where to do our validation. And you can see that we have this handler function that's already done some work. It's already decoded our admission review. It's already decoded the request. And then we get down to a switch. And the case that we care about is when we're handling a module. Now, we configured our webhook so we should only ever be called for modules. So if we didn't get called for a module, it makes sense that we'd report a failure back, which is exactly what we do in our case here, in our default case here. But let's just go ahead and look at that the case where we're handling a module and see what our code looks like now. So we've got our handler. You can see there's our informer. There's our lister, just like I expected. Here's a standard HTTP request handler. It's reading the body. It's decoding it. OK, here's our switch statement. OK, now we've got our module. And so, since we've got a no-go development environment here, I should be able to do things like module dot. See if I can do spec. Yep, OK, so there's the spec for module dot devices. And pardon me as I learned how to use German keyboards in front of you. It's actually cool. It's got a lot of nice keys. And there's our pump and our water and our sensor. Those are all three of our devices right there. So we can just take one of those. Now we've got our device. And that's literally a device name that dereferences to. And so then the next thing that we're going to have to do, and I'm going to let you guys take over in just a second, but I'm going to show you one more small step. I just left these here because Go really doesn't like it when you have unused variables. So I just left them. I told it that I wanted to keep them around. But what we want to do is we want to take that device lister, and we want to get an accessor to the current namespace of the module we're working on. So if we just do that, now we can call that lister. Stefan, take over.
I think I take over.
I'm not quite good enough at German keyboards.
So here we have a lister. A lister is basically the access to the cache, and it has a get function. So you can just take the water alarm here, and get gives us back what's on the device. We don't care about the device, actually, but we care about the error. So if the error is not nil, we have this nice errors slice there already, so we just add it. And
I think we just need the if there.
What do we need?
Did we get an if at the beginning of that first line?
Where?
Because we're doing the if, we're doing underscore and error. We're signing underscore and error, and then we're checking if error is not equal nil on the same line.
That's fine.
Oh, that's fine.
I think it's fine.
I just can't see.
Okay, it's shadowed now, but it should work.
All right.
So let's see. We build this build admission. Yeah. So in parallel, just go ahead and do the same thing. Try to deploy this. So if you say at the moment you say kubectl edit on an object and you modify a device name to something which doesn't exist, it just works. So there's nothing checking that. And our goal, of course, is to do that. So it's compiling. Yeah, so here some instructions how to do that. If you want to build it in the cloud shell. Yeah. So here we see how it would look like if our controller would work. Somehow we have a panic here. We have not implemented the logic there, so everything which happens here you can do at home or later on here in the conference. This logic which sets the pumps, it's part of the controller. At the moment it's empty, so
yeah, there's just a to-do there. If you go into the controller and find the pressure reconciler, there's just a little unimplemented function. If you implement that, you'll actually see that you're controlling how many pumps are running at any given point in time. It's a good exercise to do here at the end.
All right, so we have compiled. We use kind here to load this into kind. That should be pretty fast. And we update the manifest. So I have my long Docker IO registry name here. So let's just use the latest. And chuck admission Admission. Oh, we have to apply, of course. Admission manifests. Now Kube knows about it, and it's pretty fast, so it's already container creating. It's running 6 seconds, and if we now do, where's the module? It's a module YAML, so I added the YAML, and I just put, which one did we fix actually? The alarm, I think.
Did we do the alarm?
So we didn't do all of them, we just checked the water alarm here. So let's put something here which doesn't exist, and there we go. So it tells us the device doesn't exist. And this is exactly the string which you can pass back here. So it's this message here. You can put anything, and the user of kubectl will just see the message as an error. Cool. All right, so Wi-Fi works fine, looks like, so we can skip the warning. We are a bit frightened that it doesn't work. Yeah, so some last tasks. So we are nearly at the end of the talk. Yeah, the first step we have just done live. We have done at least one check of one of the devices here. Of course, there are 3 of them, so test all of them. Deploy that locally, play with it, maybe even try to make a mutating admission webhook and see how this works. Should be the same, so it's very, very similar. And of course, take a look on the controller. So controller, if you just run the simulator, it's boring, nothing happens. Walter will die pretty soon because the pressure moves pretty fast. Some logic which sets the pumps. So use the client Go client for devices depending on the pressure, which is read from the device, from the pressure sensor, and adapt the controllers, adapt the pumps, and get to some pressure which is near to 10, around 10.
Great. Well, we've seen a bunch today, so we can just, while you continue to work on that, we can just recap since we only have a couple of minutes left. So that's what we worked on. We worked on the research station, and hopefully you've done a good job and kept Walter alive and healthy. We covered a lot today. So we covered versioning. We talked about how you can have multiple versions in the same CRD and how to deal about that. We talked about pruning, which is a really important idea. We're moving to a really type-safe system for CRDs. That's essential for that. We talked about validation, both on single fields, and then we talked about how to validate across fields. We talked about our webhook, how to do some more advanced cases. We wrote code to update our APIs using KubeBuilder. We've looked at the controller, the code generators for that. We've looked at some open API schema in more detail. And we've basically touched every extension mechanism that you can use around CRDs. I think...
Yeah, so the versions are, of course, important. We have done a lot of work. You see at the bottom the pruning, defaulting. It's all pretty new, so you need at least 1.15 to have something. I mean, before that, certain things like pruning do not work. Conversion does not work, so 1.15 is a good bar. We know that, of course, some of you will target older Kube versions. There's not much we can do, I think. Just wait half a year that 1.15 is the lower version, I guess. Mm-hmm. And just try out those features and give feedback. They are new, but they are very well tested inside of Kubernetes. Admission is there for quite some time, and we have seen some projects, Open Policy Agent here, of course, so it's not new, but conversion is new. Please try it. If you find issues, report them. Make issues in KubeBuilder. So we have shown KubeBuilder. It's a cool tool. It has some rough edges, but we don't want to live without it, especially for Open API. It's very, very powerful. And contribute to that as well. So if you have ideas, fixes, contribute. KubeBuilder needs people.
And the Kubernetes community takes GA features pretty seriously, so it's great to have all these main features in GA. That means that we are not going to be breaking backwards compatibility or APIs. This is something you can really build on and use over time. I think that's it. Any questions? The question is, do we have regular expression-based CRD validation?
Yeah, so I showed the pattern marker. It's a regex. So you can put anything you like there. It's a pattern. For IPs, we also have, there's something in OpenAPI called format. So there's a type, string, and there's format. And there's an IPv4 format, which is then checked. So you don't have to write regexes for, I don't know, we have like 15 or 20 different formats we support. And it's not documented in 1.16. If you look in master of Kubernetes and you look on the CRD types, we just recently, some days ago, documented that. So like 20 different formats exist already. IPs, name, durations, timestamps, all those things. Yeah. If you remove a field, removing a field, it doesn't round trip by definition. So you probably, I mean, strictly speaking, you cannot remove fields. You cannot do anything with a CRD or with a CRs if you have conversion, which is not bijective or which uses data. It's just not allowed. If you change things like you change validation, it's also incompatible because suddenly objects do not validate anymore. There's one concept, maybe it also applies here. There's one concept, we call it ratcheting updates. So we allow old objects to be invalid for certain fields. We even allow to update them, but everything new is really strictly validated. So this can help sometimes to adapt or to change validation or to add fields, remove fields. For adding fields, we have defaulting. So defaulting is very helpful for that because even old objects from etcd are defaulted. So you can add fields and even have values for them, even for old objects which are created months ago. So it's pretty powerful. But deletion keeps the field, document it, deprecate it, and at some point do validation maybe and restrict it, forbid it. But keep it because round tripping must work.
Yeah. Mm-hmm. The question is admission the only way to validate a CR is created in either cluster scoped or namespace scoped? I believe it depends on what you want. You can say, when you create a custom resource, you can say whether or not it's scoped to namespace or cluster.
Yes, only just one.
So you already get out of the box the option of saying if you want this to be a clustered scoped CRD or not. And then the custom resources you create from that will automatically follow that rule. Now, if you want to restrict it further on various namespaces, you could have the option of either using like RBAC, I believe you could use.
Yeah, RBAC works, it's fully supported. But if you want to programmatically restrict the namespaces, like it should only be in kube system or in your operator, you could use admission, yeah. Mm-hmm. There's no other way.
And that's kind of the classic thing you'll see. Like for many of the common cases, you don't necessarily need to use an extension mechanism. There are components built into Kubernetes to do it. The nice thing about having very general purpose extension mechanisms like we have is for all those things where you can't find any other way to do it, you still have an option. Yes?
You want to get rid of old versions. I mean, V1, Alpha 1, in a year, you don't want to see that anymore, right? Sorry? Yes, only one can. So, yeah. One consideration is downgrades. if a customer downgrades. So if you introduce V1 and also set storage version to V1 in this moment, you cannot downgrade anymore because the cluster suddenly has V1s in etcd and the old controller cannot handle that anymore. So usually you have this at least one version delay. That's what we do upstream at least. Yeah, and after that you change it. But there's also one thing, if you change the storage version, you still have the old objects. So keep in mind you have to migrate. API Machinery has a tool, it's alpha, maybe beta now, it's called the Storage Version Migrator. It's under the Kubernetes 6, where you can tell this controller, tell it, rewrite every CRD. So after you change the storage version, tell this migrator, do the migration, and then everything is rewritten and everything is V1 if you change to V1.
Yeah, we also have on the main CRD documentation for Kubernetes, there's a list of kind of a recommended set of migration steps. I think we still have some work to get that a little firmer, but it does mention the storage migrator and kind of a basic flow and some of the considerations you might want to take there. Yeah.
Yes. Which advanced features we are planning? Yeah, there's one, I'm not sure it's advanced, immutability. There's a cap for immutability. So you can say fields cannot be changed anymore after creation. I mentioned that briefly in the API Machinery deep dive. So if you want to watch the video, it's there. It's a cap at the moment. There's implementation, but it's not merged. We target to have an alpha of that next version, probably 1.18. So this comes. We are discussing protobuf for any kind of binary encoding, but it's undecided, so it's very, very fresh. What else?
Other types, so potentially having a union type as a formal type in the system.
Yeah, union types, so that's what we did here, what I had as one of the goals, stretch goal, to verify that the union type is really just one field is used. There's a cap to add an extension to do that automatically. And similarly, we added something called a list type and a map type. So you can define for a list that it's actually a set with named objects. And we are working on validating that the name is just used once, like containers and pods. Every container has a name, and they cannot be reused. There cannot be a conflict. And this kind of check. It's impossible to declare that in OpenAPI. Admission can do it, of course, but you don't want to write code just to check that. This type, map type, that's new.
Okay, I think we're at time. I'm happy to answer any questions afterwards, but I think we're going to step down from the podium now. Thank you, everybody. Thank you for coming.